In the previous lecture, we discussed that in one-dimensional motion, we need that the body is moving along a straight line or path. We designated this straight path or street as x-axis. We have also mentioned that to locate the position of a car along this street or this x-axis, we need a reference point, which can be any known or obvious marker on the x-axis. This reference is represented by a point O. The position of the body is taken relative to this reference. So if the car or the body is 7 meters to the right of O, for example, this means that its position or initial position or position is +7 or just 7 meters because it is to the right of O. If it is to the left of O, we say that it is -7. Then if after a certain time the car is found at another position, say x2 equal 12, for example. So if you find your car or the car is at another position, x2 equal 12 meters, so you come to a conclusion that the car has moved because the definition of the motion, as we have seen, is the change in position with time. And it has moved by this displacement or distance, which is delta x equal, it has moved by 5 meters from 7 to 12. And where we use the formula delta x, the displacement or the distance x, you can call it x, is the final position or the new position minus the initial position. So it is 5 meters. So far, we have discussed two basic concepts of motion. These are the displacement and time. Now we are going to see the units of distance or displacement and time. Because in physics, units are very important. Nearly every physical concept is associated with a specific unit. For distance, the common units include, the common units used for distance are, in general, millimeter, centimeter, meter, and kilometer. However, for consistency in calculations, problem solving, the so-called the International System of Units, International System of Units, which is referred to as SI, is typically preferred. So we are going to choose among these units the one which is called the SI unit of the distance. So these are the units of distance or displacement. So we are going to use or to choose the SI unit of the distance, which is the meter. So the SI unit of the distance is the meter. So therefore, when a distance is given or the displacement is given in a unit other than meter, it is essential to convert it to meters before performing calculations to ensure accurate results. For example, to change from or to convert from centimeter to meter, we have to divide by 100. For example, let's take an example. We have also to mention how to convert from millimeter. So we'll be back to mention how to convert from millimeter. So for example, if you have 354 centimeter, this is equivalent to 354 divided by 100, which is equal to meters. So I'm converting to meters. This is equivalent to 3 point, you can use your calculator. So this is equivalent to 3.54 meters. In order to convert from millimeters, let's say a distance is given in millimeters, from millimeters to meters, which is the SI unit, you have to divide by 1000. So, for example, if we have, let's say, 857 millimeter, this is equivalent to divide by 1000 in order to convert it to meters. Again, using your calculator, it would be equivalent to 0.857 meters. Now, to convert from, so far we have seen millimeters, centimeter, and now kilometers. To convert from kilometers to meters, now you have to multiply, not to divide, to multiply by 1000. For example, if you have 7.6 kilometers, this is equivalent to 7.6 times 1000 meters, which is equal to 7,600 meters. For the time, now we have seen the common units of distance, and we have seen also the SI unit of distance, which is the meter. For the time, for the other important concept, which is the time, the common units include second. So these are second, minute, and hour. As we know, these are very well-known units of time: second, minute, and hour. Again, we need the SI unit. The SI unit of time, which is the unit that we are going to use in calculation of time, is the second. The second. So this refers to the seconds. So in case we have the unit in so it is minute. I'm going to hit here, sorry, in order not to confuse with meter. So we are going to express minute as this is the minute. So again, all the units of time should be converted to the second, which is symbolized as S. So from minute to second, in case we have in the problems or in the exercises the unit minute, we have to convert it to second. We have to multiply by 60. So for example, 5 minutes are equivalent to 5 times 60 seconds, which is equal to 300 seconds. In case of the hour, from hour to seconds, we have to multiply by 3,600. So 1.5 hour and a half, is equivalent to 1.5 times 3,600 seconds. Using the calculator, it would be equal to 5,400 seconds. The third basic concept in that belongs to motion or of motion is the so-called the velocity or the speed. So now we are going to move to this concept, which is the speed or velocity. Velocity or speed. So I'm going to the velocity, or we can call it speed. The speedometer in the car shown here, as you know, it displays the car's speed, and you'll often see the symbol kilometer per hour on the screen, which represents kilometers per hour. It is a unit of speed. So kilometer per hour is a well-known unit of speed. As we mentioned, for most of physical concepts, we have different units. So one unit of the speed is kilometer per hour, and you know that this indicates the speed of your car. Other common units of speed is meter per second, for example, or sometimes kilometer per second. For example, if the speedometer displays 80 kilometers per hour here, it means that the car travels 80 kilometers, so 80 kilometers per hour is equivalent to saying that the car travels 80 kilometers during 1 hour, or within 1 hour. Or this also means that it would travel 160 kilometers in 2 hours. Similarly, if a rocket's speed is 300 meters per second, for example, if a rocket has a speed of 300 meters per second, this means that this rocket is traveling 300 meters each second, or every second. An object that covers a greater distance in a shorter time is said to be faster. So, with greater distance in shorter time means faster object, or indicates a faster object. For instance, a car traveling 100 kilometers an hour during 1 hour, for sure, it is faster than, or is said to be faster than a car traveling, said to be faster than, or its speed is greater than the car which is traveling 90 kilometers in 1 hour, which is very clear here. So the 100 kilometers is larger than the 90 kilometers, which is almost here, or greater. So a car which is traveling at this speed is faster than the one which is traveling or covering 90 kilometers an hour in 1 hour. So the larger the distance in a certain time is the larger the speed, which is covered within the same time. And also, this car, which travels 100 kilometers in 1 hour, will be faster than the car which travels 100 kilometers in more time, 1.5 hour. So again, the larger the distance and the less the time, the faster the object. So, in fact, we can say that the speed tells us, so in general, speed tells us or gives us an idea about how far an object travels in a given time. This is why the speed is defined as the velocity or speed. So the speed or the velocity is defined as, physically speaking, the rate at which an object covers distance. This definition highlights that speed is determined by two key factors. Again, distance covered and time taken. And this relationship is evident in the units used to measure speed, such as, we mentioned that, kilometer per hour or meter per second, which expressed as kilometer expresses the distance and hour is time, is the unit of time. So similarly for meter and second. So as we are saying, distance divided by time. This is what we mean by the rate at which an object covers distance. The rate is obtained once we divide by time. The SI unit of the distance, again, we have to know the SI unit of the speed. The SI unit of the speed can also be deduced from what we have mentioned about the SI unit of distance and the SI unit of time. Since the SI unit of distance is meter and the SI unit of time is second, so we conclude that the SI unit of the speed or the velocity is meter per second. So once we are going to solve problems, we have to use this unit. In order to change from kilometer per hour, once the speed is given kilometer per hour, we have to change it to meter per second. We have to divide by 3.6. For example, 90 kilometers per hour, if the car is moving with a speed of 90 kilometers per hour, divided by 3.6, this is equivalent to 25. For example, let me write it as equation, sorry. So 90 kilometers per hour is equal to 90 divided by, or you can write it as a fraction simply. Divided by can be expressed also as the division can be expressed also as a fraction. Divided by, let me write it in the right way, is equal to 90 divided by 3.6 meter per second, which is equivalent to 25 meters per second.